Today marks a historic milestone as the first space-trained large language model is born, forged on an H100 aboard the Starcloud 1 satellite. On the ground, a tiny startup in Washington quietly prepares a giant leap by training nano-GPT on Shakespearean language. The Starcloud 1 satellite carries an extraordinary power, a graphical comparison showing it outpacing every previous space GPU by 100-fold. Gemma, Google's space-bound model, speaks first from orbit, greeting Earth with a calm, curious voice. "Hello, Earth." The moment it speaks, the line between sci-fi and reality blurs as a satellite becomes a storyteller. Karpathy's nano-GPT, trained entirely in orbit, begins to answer questions in the diction of Shakespeare. From the ship's sensors, Starcloud 1 reads its own status in real time and narrates its environment back to us. A question from Earth asks where the satellite currently is, and the answer arrives with a playful, poetic tone. The first major feat is not just inference, but the creation of a Shakespearean-voiced LLM right in space. A GitHub link to nanoGPT is shown, celebrating open-source collaboration that made this moment possible. Starcloud 1 demonstrates rapid intelligence by identifying wildfires from satellite data and alerting responders instantly. Real-time sensor data, altitude, attitude, position, velocity, feeds the model for insightful replies. Earth's data centers strain the grid, but space power offers a potential 1/10 the land footprint and limitless sunlight. Starcloud envisions a 5-gigawatt orbital data center, with solar panels stretching for miles around a cooling apron. The white papers claim space power can surpass the world's largest power plants while occupying far less land. Next, in 2026, multiple H100s will launch together, integrating Blackwell for even higher AI performance. Crusoe, a cloud integration partner, will enable customers to deploy AI workloads from space directly to the cloud. A global race begins as Google, SpaceX, and Blue Origin join the fray with space-based compute. Project Suncatcher, born at Google, aims to form a distributed compute cluster in sunlit space. SpaceX envisions Starlink satellites evolving into orbital compute backbones for AI tasks. Blue Origin's New Glenn is advancing, potentially ferrying large swarms of satellites into orbit. Even OpenAI's hypothetical space ambitions show how universal AI ambitions have become. Analysts warn about radiation, maintenance, debris, and space governance, risks that must be managed. Yet, history teaches that early movers eat the meat while latecomers drink the soup of opportunity. Meet the team behind Starcloud: Philip Johnston, Ezra Fielden, and Adi Oltein, each a pioneer of space and GPU innovation. Philip Johnston, with a background in MIT and Harvard, leads the charge toward a data-centric space future. Ezra Fielden, CTO, with SpaceX and Oxford Space Systems experience, designs scalable space GPUs. Adi Oltein, Chief Engineer, brings decades of GPU clustering and SpaceX software leadership to Starcloud. The mission is clear: push AI beyond Earth's cradle while protecting our planet's energy and water resources. In this cinematic journey, we witness science fiction crawl into reality, scene by scene. A closing note from the narrator: the universe is a laboratory, and humanity is just beginning to experiment at orbital scale. Prepare for the next launch window, as orbital AI ushers in a new era of computation beyond gravity. The first space-trained LLM is live, and the dialogue between Earth and orbit has begun. From Shakespeare to practical safety alerts, this model demonstrates the versatility of space-enabled AI. And so the story continues, as scientists, engineers, and dreamers watch the night sky and imagine what comes next.